This is a video of a break-even exercise found on page 21, exercise number 12. It is described as follows. You can read it on page 21. The O'Neill Shoe Manufacturing Company will produce a special style shoe if the order size is large enough to provide a reasonable profit. For each special style order, the company incurs a fixed cost of $2,000, which I wrote down here as the fixed cost for the production setup. The variable cost is $60 per pair. Variable cost, $60 per pair. And each pair sells for $80, which is the price. Now, how do you find the break-even point here? There are other questions in the problem, such as let X indicates the number of pairs of shoes, etc. Develop a mathematical model. All of those questions will be answered as I answer the question about the break-even point. Well, at the break-even point, total revenues are equal to total cost. And total revenues by definition is equal to price times quantity. And this X here is the amount of units that I'm going to produce, or what is just called the decision variable. And that is equal to total cost, and the total cost there is the fixed cost plus the variable cost, which is the variable cost per unit times the number of units. So P times X, which is the total revenue, I'm going to replace the number. The price is 80, so it's just 80X is equal to the fixed cost, which is $2,000, plus variable cost per unit, which is $60 times X. So that is our problem. And now all you need to do is just solve this simple system of one equation, one unknown. Just collect common terms, subtract 60x on both sides, and you get 80x minus 60x equals 2,000. And 80x minus 60x is 20x equals 2,000. And if we divide by 20 on both sides, x is equal to 2,000 divided by 20. And therefore, x is equal to 100. Now that is the solution to the problem, and this is the break-even point. Now graphically, if this is on the horizontal axis, the x, if we measure on a horizontal axis of a graph the amount of units produced, this point is 0. And here we're going to have the dollars indicating total revenue, total cost. Okay. What is the total revenue function? The total revenue function is 80 times X. So total revenue equals 80 times X. Well, that is a very simple line. Is a line that if you recall when you do this in math, the equation of a line is mx plus b. But this line only has the portion mx here, the slope times x. So there is no vertical intercept, or the vertical intercept is 0. So 80 times x is just a line that is upward sloping like this. Total revenue equals 80x. And the total cost, as you may recall, is equal to 2,000 plus 60x. So if we choose a number here as our 2,000, and then notice this is a line, total cost, let me repeat it here, equals 2,000 plus 60x. This is a line that has a vertical intercept of 2,000, and then it rises by 60 times x. So it's a line that goes like this. And both lines are going to intersect right here. And I know they're going to intersect because this line has a slope that is 60, and this line has a slope of 80, which is higher than this one. So the total revenue has to be steeper than the total cost function, or total cost line. And they're going to intersect right here, and that point is where my 100 units are. So that is graphically what we did before, just with the equation. So that is the typical break-even point problem. And I'm going to post also another video that shows how to solve a problem like this using Excel. Good luck.